businesses, they have the benefit of learning from the legacy commercial operators and the benefit of learning from those commercial models. But in the last several years, there's been increasing activity from entrepreneurs to take on a much more daunting technical risk that is, frankly, commercially uncharted, as they look to develop markets in an extraterrestrial world. So on this panel, we're going to hear from these new entrepreneurial companies and learn what compels them to build businesses that are focused beyond our world. And how do they see their businesses evolving beyond what is today probably a predominantly government-backed ecosystem? And how do they literally pitch these out-of-the-world business ideas to the capital markets, to the investors? So I think we'll first start, we'll go down the row. Please introduce yourself and then give us your 30-second elevator pitch when you meet investors, how you convince them and how you energize them to pour money into a business that has never been done before.
Yeah, so again, I'm Masayuki Urata, manager for Indo-Pacific Sales iSpace. And as iSpace, we are providing lunar transportation service, but we would like to, we would not like to limit our scope just for lunar transportation service. So our, mission is to let customers to realize lunar missions. And so each customer has several expectations or requirements. And our intention is to provide various services, not only for lunar transportation service, in order to maximize the value of the customer's lunar missions. So thank you very much.
Hi, my name is Ryan Wiltshire. I'm the VP of Business Development on behalf of Impulse Space. So Impulse Space is a company that wants to enable the space economy by enabling efficient in-space transportation. So what does that really mean? That means high delta V capabilities for high energy orbits, which in this case we're going to be talking about beyond Earth, but it also means LEO to MEO to GEO. So the question was posed on how do we go to investors, how do we talk about this? For us, it's a stepping stone in terms of engaging the community here with commercial business cases and help them close that. Also with government customers in the LEO, MEO, and GEO kind of ecosystem that has a good backing and funding both from a commercial and government perspective, and then develop and move on to cislunar and interplanetary missions from there. Thank you.
Hi, my name is Craig Mull. I'm the Director of International Development for Intuitive Machines. We're a publicly traded company. In the States, we've successfully landed on the moon earlier this year with our IM-1 mission. We've got another one coming up in the first quarter of next year, another a year from now, and another couple of years after that. How do we present to the market? Each of those missions I described, of those 4 lunar lander missions, are anchored by a NASA commercial lunar payloads contract. And that pays for some of the cost of a mission. But we've got additional payload that we sell to commercial entities, to foreign space agencies, and to other folks who want to go to the moon. Essentially, we're selling lander capacity by the kilo.
Okay, thanks. And maybe we keep with Craig for now. So can you tell us a little bit about Intuitive Machines' origination? Is what you guys are doing today the original vision of the company? What were some key milestones? You talked about the lunar lander. What other milestones were achieved recently? And what were some painful learnings that have come along the way?
Yeah, there's plenty of pain in the lunar lander industry. Our origins are from NASA. Two of our founders are former NASA Johnson officials. Our CEO was the deputy director of Johnson Space Center. We know how to win NASA contracts. We've got 4 of 9 commercial lunar payload services contracts that have been awarded by NASA. So the name Intuitive Machines is funny. I was having lunch today with someone who said, well, you must be in the AI business with a name like Intuitive Machines. We were actually intended initially to be a think tank. And then when NASA allocated $2.6 billion to the CLPS programs, Commercial Lunar Payload Services program, we realized, hey, we can do that. And we were fortunate enough to land softly on the moon in our first attempt. Painful lessons. The story that I've heard is that we had 85 problems in the course of the mission, from takeoff to landing. 85. And we solved them. We were able to achieve our mission objectives. My favorite story here is that we were, when we landed, we had a problem with a laser altimeter, and our lander clipped some rocks on the lunar surface and broke a leg. So when we landed, we sort of tipped over a bit. We were able to achieve our mission objectives, but our high gain antenna was pointed right at the surface of the moon. What we learned was that we could still close the link in S-band to our friends on our terrestrial network, like Parkes has a 64, in Australia, has a 64-meter antenna that worked quite well. We were able to close the link. We were able to get the payload data off of the lander. What we also learned was that that data, not so much what the substance of the data, not the payload data per se, but the multipath. We actually got an inquiry from NASA to buy to be able to characterize the multipath, because they want to understand what happened and how we did it. So there's a lot to learn. This is dangerous stuff. It's hard. Landing on the moon is hard. Space is hard. Landing on the moon is hard. There will no doubt be 85 more challenges that we face on subsequent missions. We will have solved all 85 of the old ones, and we'll find 85 new ones, no doubt.
And Ryan, origination story and achievements and painful lessons.
Yeah, sure. So founded in 2021, so we're relatively new. One of the kind of achievements I'll say is, or actually taking back a step, so our CEO is Tom Mueller, who employee number one over at SpaceX. He developed the Merlin 1D engine, Merlin MVAC, and Raptor, and so he brought over a lot of the teams, not only from propulsion, but also structures and kind of other critical subsystems that you would associate with the kind of programs like this, right? So a lot of what I'll be talking about is kind of very SpaceX from a, break a lot of things, break them fast, break them hard, learn, iterate your design, and go back and break them again, right? So we did our first vehicle, which is called Mira. It's an OTV, about 300 kg worth of payload capacity in LEO. So we did white sheet design to manufacture to launch in about 15 months. And that was, by all metrics, kind of a complete success. It's actually still in orbit about a year ago. We launched it, so it's still up there, and we're actually going to do some work with it once we launch our second Mira here in a few weeks. But the painful lessons were kind of learning some things on the fly, right, with your first mission, right? So we had communication and other issues that extended kind of the life cycle of what we thought we would hit, and really got the teams kind of moving in various directions that they didn't foresee, right? But this is kind of, again, space is hard. You're not gonna, there are some things that are just unknowns, and the only thing you can do is kind of test as you fly, right? And so not nearly as much as maybe 85 aspects that we burned, but we definitely had our hair on fire for that first mission. And you kind of utilize those lessons learned into the second one, and that's how you kind of walk the development path, right? And so that's kind of the mission that we're on right now. Thank you.
Yeah, so actually, iSpace started our own company as a rover development company. So our founder, Mr. Takeshi Hakamada, participated in the Google Lunar X Prize. Yeah. Then we tried to deliver our own rover to the lunar surface. But as a result, so it hasn't been realized due to the absence of lander. Yeah. Then our founder, Takeshi, is, how to say, has a very great luck. And at that time, he met with a great investor, and he asked Takeshi, so how much do you need to develop its own lander? Then he replied, around 100 million US dollars. Then this investor decided to coordinate with other venture capitals and other companies, then realized like a biggest Series A fundraising in Japan ever as a space startup. So this was the, how to say, starting of iSpace as a lander development company. Yeah. So this is like a old story. But when it comes to our first mission, so as I mentioned, so it was ended as a hard landing. And actually, so the lander, how to say, misinterpreted its location. And when lander reached around 5,000 meters, like 1 mile above the lunar surface, so that lander thought, so it's already on the moon, and waited for physical contact. But of course, there's no physical contact, and then ran out of the fuel and started free fall. So in such regards, maybe the distance between intuitive machines and iSpace, 1 mile maybe. But anyway, the good point is, so we identified the root cause, maybe 85. So, and the second important point is we disclosed such analysis on the YouTube, and also in order to like support each other to, how to say, develop lunar ecosystem. And after the landing attempt, so we had a meeting with NASA, and NASA evaluated highly on our such like open mind attitude. So, and it was, how to say, good lessons learned. So to keep open. So yeah, thank you.
And I think you just mentioned your next launch is in December?
Yeah, at earliest. Yeah.
At the earliest. So is that lander, how can you, how different is it from what you attempted the first time? Are there a whole bunch of upgrades and a whole bunch of growth, or did you focus on just trying to fix the key things that were learned, try to make a landing, or how much of an upgrade is it?
Yeah, so in terms of hardware, we found no failure for the mission 1. So there was no necessity to like replace some components or change the design in terms of hardware. It is really lucky, and there was no, how to say, schedule impact for lander development. And software side, so of course, so we like analyzed the root cause and adjusted parameter. And also, so the second problem was like related to program management. So when we conducted like a landing simulation, we haven't included the deep cliff on the, rim of the crater. So it was one of the reasons that the software misinterpreted the actual height. Yeah, and we will, well, we have already, how to say, reconsidered or restudied the, how to say, area for the simulation. Yeah, and by, how to say, reflecting such lessons learned, so we are now confident that we will get more better result for the mission 2. Yeah, thank you.
And Craig, your guys' next mission, what's the timeline, estimated timeline, and how are you guys approaching upgrades, limited upgrades, lots of upgrades? What's the approach based on your lessons?
Yeah, thanks. So the IM2 mission is scheduled for launch in the first quarter of 25. It's the same spacecraft. It's the Nova C spacecraft. It's capable of landing 130 kilos of payload on the lunar surface. It's a more ambitious mission than the first. The first mission, all of our payloads on the lander were static payloads. On our next mission, we have a number of mechanisms. As an old satellite guy, it's mechanisms that make my heart go pitter-patter, or maybe my throat constrict and my blood pressure raised. We have a couple of rovers on this mission, so we've got deployable mechanisms to put those rovers on the surface. On those rovers, we have one of those rovers has a neutron spectrometer. There's also a neutron spectrometer on what we call a micronova or a hopper. This is really cool. It's a small satellite that will launch from the side of the lander. After we land successfully, this small satellite will launch and it will hop into a permanently shadowed region in a crater and take neutron spectroscopy measurements. So there's a lot of mechanisms. It's a very ambitious mission beyond our first. So we've tried to keep everything else, except for that laser altimeter, we've tried to keep everything else the same. Our first 4 missions are all on the Nova-C lander, so there will be slight improvements, but I would say nothing radical. The next big inflection point for us will be the Nova-D lander, which is an order of magnitude more landing payload capability to the surface, 1,500 kilos of payload to the surface. So that will be another big inflection point. But it's worth saying that when we first designed the Nova-C, we didn't see demand beyond 100 kilos of payload to the moon. Now we're seeing multiple missions that are looking for a metric ton or more. So like our friends at iSpace, we definitely see requirements for heavier payloads and more opportunity there. So we'll be scaling our Nova-C into a Nova-D by simply, actually, our structure of a Nova-C is a hexagon. And then we'll actually strap 7 of those together to create a 4.5 meter diameter lander for the Nova-D. So it's essentially the same technology, although you can't. It's not never 100% the same, but essentially the Nova-D will be 7 Nova-Cs.
Okay, and Ryan, maybe a unique question for you. So you mentioned you guys are looking to service different LEO orbits, probably MEO orbits, GEO orbits, talking lunar in this panel, one day even beyond. So, as you guys think about your company, your engineering resources, your financial resources, is that too many beachheads? Too many different missions for a team that's still, developing and perfecting your product. So yeah, can you tell a little bit about how do you guys resource out time, money, engineering resources to all these various Earth orbits, or is the platform so modular and so uniform that maybe it's not as big of a deal?
Yeah, I mean the simple answer there is a technology development path where we kind of methodically add capabilities as we move along and we mature as a company, but also mature our vehicles and get that flight heritage in terms of space and mission and different mission profiles, right? So as you mentioned, right, we're an enabler, right? So I hope both of these individuals are future customers of ours, right, where we enable their missions to be even more effective, right, even more down mass in this instance in terms of kilos to the lunar surface, or enabling other mission profiles for other kind of cislunar activities that they might be involved in as well, right? So, we have, as I mentioned, a Mira mission already up for the past year. We got another one coming up in another few weeks, and that one will be, again, kind of upgraded hardware, but also, commercial and government payloads on it as well. And then, to your question, right? So we've got 2 vehicles, the other one being Helios, which will be, kind of an enabler for both of these individuals that kind of goes 4,000 kilos to direct to geo insertion. From a TLI perspective is about 6,000 kilograms and about 4,500 kilograms Earth escape trajectory, right? So getting a lot more capability. In this case, those numbers I mentioned are on a Falcon 9. So when you strap Helios, our vehicle, to a Falcon 9, you kind of enhance the capability of that launch vehicle and enable some of our customers to have a little bit more either flexibility and dynamics with the missions that they take on. But again, to your question, it's really being methodical in terms of the critical subsystems that are shared between those two vehicles, and having a rigorous development path from a critical subsystem perspective, right? Propulsion, very similar in terms of our approach there, because this team, came from the Raptor program, came from the Merlin M1D and M1D VAC program. So, and then you kind of go down the same path, avionics and some things that scale very well. So Mira, which is a much smaller vehicle than Helios, you have some scalability there. So a lot of these things kind of are in tandem and parallel path. So for some of these longer duration, deeper space missions, those are going to be further out, 2027, 2028. So not trying to bite off everything all at once. We're methodically kind of moving down that as we kind of prove out capability.
And iSpace and Intuitive, there's a lot of things you guys do that are matching each other, stepping with each other. So speaking of kind of just fractionally managing various funds, both of you guys have announced lunar data relay services. Again, from resources at the company, priorities at the company, how do you guys manage that? What's the highest priority? What's the secondary priority? And then a little bit about do you guys see in that lunar data relay market enough business for both of you? So maybe start with Craig first.
Sure. The lunar data relay network. We were awarded a contract for Near Space Network constellation of spacecraft, so we'll be launching our first spacecraft in about a year on the IM-3 mission. We'll be dropping that spacecraft into elliptical orbit over the moon. We plan 5 or 6 of those spacecraft at the end of the day. This is a network that is by fiat. It needs to interconnect with the European Moonlight program. Our program includes 1 million minutes a year of traffic to NASA. And I think it's instructive to say that our model is, and I say this, I hope, in all modesty, we know how to win NASA contracts. We know how to bid them. We know how to win them. They don't close the business case. They facilitate a business case that is commercially driven. They help, but they don't close the business case. The big moment for us on a communications basis is when we can survive as an industry, survive the lunar night. As you probably know, the lunar night is 2 weeks of sun and 2 weeks of shade. Most missions that go to the lunar surface last a fortnight, and they don't survive the lunar night. So as an industry, I don't think we're very far away from solving that problem. I think we're close. But until we solve that problem, our traffic will be episodic, right? And most lunar lander missions last 2 weeks. It's tough to sell 1 million minutes in 2 weeks a year, though that is my job. So in terms of resources, we are a commercial entity. We're commercially traded. We're commercially minded. It is what we're excited about is a model where NASA is we're meeting mission objectives that they have, and they're able to fund part of a mission, and they're buying a service from us. At the end of the day, they're not buying a lander. They're not buying a rover. They're not buying a satellite. They're buying minutes, or they're buying payload to the lunar surface. And that model is very much a commercial model that drives our decisions. We're going to make a profit. We're in business to make a profit. Our shareholders strongly believe in that. I would say in terms of resources, and manpower, or workforce, we're growing fast. We're now at about 450 people. A lot of those have come on since we were awarded the NSN contract. That's going to be that's a substantial business in its own right, besides just the lander business.
Rada-san, a bit about
Yeah.
your data relay?
Yeah, thank you very much. So when it comes to iSpace, so as I mentioned, so we are planning to launch Mission 3 lander in 2026, and we are going to bring 2 relay satellites together, and those satellites will be our own assets. So we decided to take some risks to start such communication service by ourselves. So this is the situation. And a good point is, so we have already several payload customers for Mission 1, Mission 2, Mission 3, and onwards. And we have close communication with such payload customers, and they can be potential customers for our communication service as well. So it is very nice and helps us a lot. Yeah, and when it comes to the another aspect, so as you may know, in Japan, so recently, Space Strategic Fund has been launched, and Japanese government decided to invest around $6 billion US in 10 years. And there's some potential, project related to communications. And now we are in discussion with such potential partners to collaborate under such program. It is one of our, uniqueness of the business environment. Yeah.
Thank you. We have about 5 minutes left. I want to take an opportunity if there are any questions from the audience. We got a couple of them there. So let's go for that first one. So what are your approaches in securing commercial payload customers? Do you differentiate customers doing experiments versus courier passengers, getting items to leave the moon, live on the moon, leave on the moon? There's courier passengers getting items to live on the moon. Yeah, so I guess first, maybe for whoever wants to take this one, feel free to jump in.
Our approach is whoever wants to fly, we will take to the lunar surface. We are not picky. Our plan is to land every year. We want missions that launch and land every year, so there's a regular cadence. We think that there are substantial opportunities for agencies and commercial entities that want to either advance the TRL level of their hardware, or they've got instruments that they want to put on the surface, or they want to do testing and mapping. There are many opportunities. One of the things I haven't discussed much is that we process the data from the lunar reconnaissance orbiter that NASA is flying. So we have those data. We process those for data. That helps tell people where to land when you're looking for, when you want to land a lunar mission. There are interesting ways that we can monetize opportunities. I described our neutron spectrometer. That's there's a data play there, right? You can gather neutron spectroscopy data and sell that to lunar agencies, or to space agencies that want to base some research around that. So we're creative in terms of the opportunities. It's not just a parcel to the surface. It can be putting something in orbit, it can be putting something on the surface, it can be actually selling those data and monetizing those data.
Rada-san, any thoughts on how you prioritize?
Yeah, basically same position, but so as an example, so we accept space agencies payload like JAXA or MBRSC, including static payload, and also like a rover as well. And also maybe I may introduce one interesting payload developed by Moonhouse, so Swedish company. So they developed a small Swedish house, and we are going to deliver this small Swedish house to the moon and put this small house on the lunar surface